C3,
H6O
H6O
plus O2
plus O2, and it yields
either like a combination, a double replacement, a combustion, or a decomposition.
So this is a hydrocarbon and oxygen. It's called a hydrocarbon because it has carbon and hydrogen in it. And obviously that's O2, so it's just oxygen. So whenever you have a hydrocarbon and oxygen, you always get a combustion reaction. So the products are always going to be CO2, which is carbon dioxide plus water. And then we're going to go through the exact same thing that we did before. So what do we balance first?
Probably the carbon.
The carbons. We balance carbons first. How many carbons you got there?
3.
How many you have there?
1.
So what number goes here?
3.
What do we balance next?
The oxygen.
Oxygens are always last.
Hydrogen.
So how many hydrogens do you have there?
You have 6.
How many hydrogens do you have there?
That's 7.
That's H2O. That's a 2. So how many hydrogens do you have there?
A 2.
So what number has to go in front of here?
You have to put a 3.
All right. Now we count the number of oxygens on either side.
So with the 3 going to there, there's 6, and then there's 3. So total of 9.
And how many oxygens do I have in this compound?
1.
So I take that number minus that number. So we have 9 minus 1 for a total of how
8.
many? Is that number odd or even?
Even.
So now that's the number that I'm going to use to balance this number of oxygens there. So what number goes in front?
8. No, sorry, 4.
4. And that's how you balance it. So you have 1 mole of that. You have 4 moles of that, 3 moles of that, and 3 moles of that, and it's balanced.
And so is that like a combustion reaction?
That's a combustion reaction. All right. So even if you have oxygen in your hydrocarbon, you count the number of oxygens that you have in that hydrocarbon and you subtract it from the total number that you have on this side. And then that's the number that you're going to use to balance them. Okay?